In this video, we're going to go over trigonometric ratios. So what it means is that we're going to use the angle, in this example, angle B and angle C, tie into the SOHCAHTOA definition of each trigonometric function, sine, cosine, and tangent, and using its sides. So before we do any trigonometric ratio, the first thing we're going to do is, given a triangle, we're going to identify our hypotenuse. Hypotenuse is always the side across from the right angle. So the side with the 13, that's going to be our hypotenuse. Alright, so we're going to do sine, cosine, and tangent for both angle B and angle C. So we're going to start off with angle B. So if I were to do sine of B, which is opposite over hypotenuse. Now, from B, this is the hypotenuse, so what's across from it, or opposite of B, is 5. So, opposite over hypotenuse, so opposite is 5, and my hypotenuse is 13. So that will be my ratio for sine B. Now if I were to do cosine of B, which is adjacent over hypotenuse, so adjacent means next to it, so the side that is next to the angle B, right here, so this side is next to angle B, so that means it's going to be 12 for adjacent. And then my hypotenuse stays the same, which is 13. Alright, last, I'm going to do tangent of B. So tangent is opposite over adjacent. So tangent of B, so first is opposite. So the side that is opposite across from angle B is this one right here. So this will be the opposite side from B, so 5. And then the side that is next to B is 12. So this will be the ratio or fraction for sine of B. This will be the ratio 12 over 13 for cosine of B. And this will be the ratio 5 over 12 for tangent of B. So that's all you have to do when identifying and labeling your trigonometric ratio. Next, I'm going to make room, and then we're going to do angle C. Okay, so same thing, sine, cosine, and tangent. So the first one, so sine of C is, again, opposite over hypotenuse. So we look from angle C, and then we look for what is across or opposite from C. So if we look, this is across or opposite of C. So 12 will be the opposite. And hypotenuse stay the same, so 13. So sine of C is 12 over 13. Alright, next we're going to do cosine of C, which is adjacent over hypotenuse. Alright, so adjacent means next to C. So this will be next to. So from angle C, the side that is not the hypotenuse but next to C is 5. And then hypotenuse stays the same, so it's going to be 13. So cosine of C is 5 over 13. And then last, tangent of C is opposite over adjacent. So to review, from angle C, what's opposite or across from C is 12. So 12 will be opposite. And then adjacent means the side that is not the hypotenuse. So adjacent is not the hypotenuse, which is this one right here, that's next to C. So that's going to be 5. So the ratio for tangent of C is 12 over 5. Now if you can simplify the fraction, do so, but leave it like that. So sine of C is 12 over 13, cosine of C is 5 over 13, tangent of C is 12 over 5. Now, the reason I did sine, cosine, and tangent for angle B and angle C is so that you can see the process, especially when you're given a problem, and if I were to only ask you, say, cosine of C, you should be able to do this. Or, if I ask you for sine of B, you should follow the definition, opposite over hypotenuse, and then connect the sides with angle B. Or if I ask you for tangent of B, then again, follow the definition, opposite over adjacent, connect the sides with angle B, which one is opposite, which one is adjacent. So I'm not going to ask you for all trigonometric functions, meaning I'm not going to ask you for all sine of C, cosine of C, tangent of C. You should be familiar with sine, cosine, and tangent. Just be aware which angle I'm asking for and which trig function I'm going to ask for.